Metal ball A that carries 1 coulomb of net charge is in contact with an identical metal ball B that carries -2 coulomb charge. When they are separated, what is the net charge on each ball? How many electrons are moved during the process, and what is the direction of the charge movement? So, to figure it out, we first need to figure out the net charge when they're both in contact. So, the net charge is simply the summation of all of the charges. So, when they are in contact, it is the sum of the charge of ball A plus the charge of ball B. So this is simply equal to 1 minus 2, which gives you that after the contact, the net charge is -1 coulomb. Now, that -1 coulomb, it is the overall net charge of the system when both are in contact like this. But once they separate, they actually each only have half of the charge, since this -1 coulomb is spread out throughout the entire two balls. So when you separate them, each ball carries away half of the total charge of the system. So you just have to divide this by 2. So the charge on each ball after the contact, it's -0.5 coulombs. So after separation, the net charge on each ball is equal to -0.5 coulombs. That's the first part. Now we're asked how many electrons are moved during the process and what is the direction of the charge movement. So we know that the charge in coulombs is equal to the number of electrons times the base charge of an electron. And the base charge of an electron is 1.6 times 10 to the 19th, 10 to the -19th. And that is the base charge of an electron. So to find the number of electrons, we just have to divide the charge by the charge per electron. So get that the total number of electrons is equal to the net charge of -0.5 coulombs divided by 1.6 times 10 to the -19 coulombs per electron. And then simplifying this, you should get that it is about 3.1 times 10 to the 18th electrons. And that is the number of electrons that is transferred. So that's the second part of this problem. And to figure out the direction of the charge movement, if we look at our two balls, A and B, and let's say this one starts with 1 coulomb and that one starts with -2 coulombs. So the electrons are going to go from the negative part, where there's an excess of an electrons, to the positive ball, where there is a deficiency of electrons, since there are too many electrons here and there's not enough there. So the movement of the electrons will be from ball B to A. And that is how you would solve this problem here.